All right, we'll talk about NAT briefly. Not briefly, it'll probably take like half an hour to talk about NAT. But anyway, NAT, Network Address Translation. That is how one of the ways that we saved ourselves from the fact that we were going to run out of IPv4 addresses. We started putting private RFC 1918 addresses on our private networks, and then we use NAT on our routers, firewalls, whatever we have at the edge of our network to translate those private addresses to public addresses. So there are three different methods of NAT we're going to talk about: static NAT, dynamic pool NAT, and then dynamic overload NAT or PAT, port address translation. So this is a template file that you should be able to get from Desire to Learn. Basically, I want you to configure it. We'll put public addresses out here on all these. What's the public address? Well, anything that doesn't start with 192.168, it doesn't start with 10, and it doesn't start with 172.16/20 network. So that'd be anything 172.16 through anything 172.31. So pretty much any of those addresses that fall outside of the RFC 1918 range will be sufficient. So obviously this will be one subnet, this will be another subnet, this will be another subnet, and this will be another subnet. And we're going to use /24s on our router to router interfaces so that the everything works as expected. I pause for dramatic effect and also to take a drink of my coffee. So this is what you guys are going to start with. We're going to put the same private addresses on all the LAN. So this is a router interface. This is a PC simulating a VLAN on that router interface. This is a separate router interface. This is another PC simulating a different network on that router interface. And we have 10.1.1.2 and 10.1.2.2. And we're going to do the same thing for all three of these sites. And then we're going to configure static NAT on one of the routers. I'm going to do that on router 1. Then we're going to do dynamic NAT on another router. I'm going to do that on router 2. I'm looking at the lab sheet so I can make sure I know what we're doing, what we're supposed to be doing. I'm going to do, make sure I called it the right thing. Let's see. Static, pool, and overload, or PAT. So we'll do static, pool, and then overload. So at this point, you're going to go put all the IP addresses on everything. The only routing we're going to have is a default route on this router pointing to that router, a default route on this router pointing to that router, and a default router on this router, default route on this router pointing to that router. So we are only going to do that. This router is only going to see the public addresses because we're doing NAT, so that's why we don't need to do any special routing on this router. And this host is going to have a gateway of this router, so it's going to send its traffic to this router. This router is going to know about the different networks because they're all connected. So because of the NAT, that's going to work. So at this point, you guys are going to go configure all that stuff. I've already done that in advance. So this wouldn't take me so long. So I've already got all my IPs and stuff ready to go. And I'm ready to configure the NAT. I'm going to do the dynamic or overload first because we've done that before. Right? We did that in 220. Right? So a couple things I need to do. I need to configure my interfaces. I need to tell my router which interface should be considered inside and which interface should be considered outside. In this case, I'm going to have two inside interfaces and one outside interface. My outside interface is going to be serial 000, and my fast Ethernet is going to be inside. So I'll do Ip NAT inside on both of my fast Ethernet interfaces. And then on my serial, which I think was 000, right? Is that right? Yeah, my serial, I'll do Ip NAT outside. All right, so for dynamic NAT, we need to create an access list that's going to match our internal network's traffic. So I'll use a standard access for list for that. Permit 10.1.0.0, 0.0.255.255. So that's a access list that's going to match my inbound traffic, my traffic on my internal network. And then I need to create the NAT, Ip Nat, source, Ip Nat inside. source list 1 interface FA serial 000 overload. So we did this command in CNT 220, right? We did this command in CNT 220. It basically says, hey, configure NAT, anything that comes in the inside interface, I want it that matches list 1 should get the IP address of serial 000. Overload means that we also want to do port address translation. If we don't put the overload keyword on there, then we can only have one particular source to destination mapping. So we need the overload keyword for that to work. All right, so now that we have the dynamic overload NAT configured, we can try to ping the other side. Hopefully it'll work. What? So we can ping out and it goes across, and we can verify what happened by looking at the command show Ip Nat Translations. That shows 12.1, 10.1.1.2, the outside addresses. So that shows that, and we can also look at show Ip Nat statistics to see what happened. We have 4 hits, misses. I had a little error a minute ago. I fixed 24 misses. And also, if I go over here and ping, it should work now. If I look at my show Ip Nat translations again, now I have translations for 2.2. So, yeah, so that's dynamic. Everything goes out with the same address. Dynamic PAT, I guess I should say, overload. Working our way backwards, the next one is pool. The configuration for the pool, same way, same thing, essentially. Not the same thing, very similar. We need to configure the interfaces for inside or outside. We need to configure serial 000, which let me make sure which interface I'm using on this guy. 000. Ip Nat outside. All right, and then we need to configure the NAT. We have to create a access list again. So access list 1 permit IP 10.1.0.0, 0.0.255.255. Permit, oh yeah, standard access list. Don't need that IP. And then we need the NAT, Ip Nat. Wait, sorry, we got to create a pool. Ip Nat pool, NAT pool. Start address. So this is where we define addresses that we want our traffic to be natted as. Our router on this, our IP on this router is 14.0.0.1. So I'm going to create a pool that's in the same subnet as that, is 14.0.0.2, and then end IP address 14.0.0.10, if you will. So that's going to give me 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to be 9 addresses for my pool. Netmask, and then we'll put a netmask. So that'll give me 10 addresses, 9 addresses for my pool. So now I need to reference it. Ip Nat inside source list 1. This is very similar to what we did a minute ago, but instead of doing interface, we're now going to do pool, and we're going to put the name of the pool, which was NAT pool, and then we're going to put enter. We're not going to do overload in this case. We're just going to do dynamic with the range, right? So in this case, we have show Ip Nat Translations. In this case, we have 9 addresses that could be used. So if we had 9 hosts, that would work great. But once we had a 10th host that tried to access the internet using our NAT pool, then it would fail. So let's go ahead and make sure this works. It didn't work. Oh, I forgot to put IP on there. 2 10.1.1.1. So now let's try. So now we have 1 allocated, 0 misses. We look at translations. We show that we have a translation. 1.2 is getting translated to 14.2. These outside addresses are the addresses you're going to for the configuration. Let's check this one. All right, so if we go look at our statistics, we have 2 allocated. So in theory, if we had enough machines on here or a small enough pool, then it would fail. So why don't we actually do that for fun? I'm going to go change the pool. I'm going to change the pool to 2 addresses, and then I'm going to add another host to my network. So let's do that. Conf t. Let's see. No. Oh no. Clear IP NAT. Clear. It's a shame they didn't implement all the clear commands. Maybe it's a global command. Clear IP NAT. Oh, translation. Cool. Oh, star. Huh. That's not what I wanted. All right, so now I want to do now let's get rid of that. No IP. Copy that stupid line. No. I guess I gotta get rid of the other command first. And then no. So then I want to recreate the pool with 2 addresses. Now reapply the pool. All right, and then I'll put a switch in over here. Then I'll put another PC out there. And I'll connect that guy. All right, so now 10.1.2.3, 10.1.2.1. All right, so now I have a pool that is 2 addresses big, right? So let's go look at our stuff. Show IP NAT translations, none. Show our statistics. I have 2 addresses. So now if I ping on all of these guys, assuming it's going to work, or not. What the heck, man? All right. I don't know why the ping's not working. All right, let's ping from down here for fun. All right, that one's working. Why is this one not working? Well, now, who cares if it's working or not, right? At least it shows up into the thing. Statistics, 100% allocated. So now if I try to ping from here, it will not work because there is not a available NAT address for that. So if we look, I have misses of 1. So if you're ever in a scenario where things kind of work sometimes but other times don't work, especially in a small network, then maybe the NAT's not set up right. So sometimes you don't have enough traffic going out that is causing the NAT to be hit. I don't know why it's not working. I'm going to pretend like it is. Let's just pretend like that's working because I don't feel like messing with that. But that demonstrated one way. We have a pool size of 2, and we have 3 hosts, so that fails. So that's why we needed the overload keyword. If I was to put the overload keyword on there, then that would work okay. But I'm not going to do that because I did that down here. The last way we're going to do NAT is we're going to do static NAT. So with static NAT, for each host, we're going to specify specifically which address it should be using. So in this case, we need to do the same thing. Go into the interfaces. Our FAs are inside. Our serial. Let's see, make sure we're using 000. 000 is outside. Outside. And now for the NAT, we need to do IP NAT inside. Static inside address 2, so that's the actual IP address of our inside host, and then we're going to use an IP, available IP on our network. So we're the 13 network over here, so I'll just use 13.0.0.2. All right, so that created the static NAT. So now in theory, I should be able to ping from this guy 15.0.0.2. All right, let's go look at our stuff. Show Ip Nat Translations. So I have the translation, and if I look at the statistics, misses. All right, let's see if I can figure out why it's not working. Let's go ahead and, if all else fails, look at the config example in the book, right? All right, static, IP NAT inside, IP NAT outside. IP NAT inside, source static, inside global. So that's what I did, right? So in this case, our inside is 10.1.1.1. Our outside, we're going to use 200.1.1.1. So inside IP NAT inside source static. what I did. Ip Nat inside source static. Oh. That's probably the same problem I had a minute ago. I used the IP of the other router for my NAT. So yeah, that's not gonna work too well. Yeah, not gonna work too well at all. So my other router is 13.2. So I have router interfaces of 13.1 and 13.2, and I just said, hey, I want you to use the other router's interface for your NAT, which is pretty stupid. So let's get rid of that. Copy. Did I copy that? Why is copy not an option? Whatever. No Ip NAT inside source static 10.1.1.2. Oop. All right, so now we'll redo it with 13.3 and hope for the best. That makes a lot of sense. Yeah, I mean, that was part of my grand plan to screw that up on purpose so you guys could learn from my intentional mistake that was 100% intentional. I even made it intentionally on the dynamic NAT as well. So that one worked. This one's still not going to work because I don't have a NAT for it. 15.0.0.2. So that one's still not working, right? So then I need to put in another NAT for that one. So I need to say anything that is 2.2 needs to be 13.4. All right. So that is the static NAT. Problem with static NAT is you need one NAT for every address you want to use. Benefit of static NAT is it is the only one of the 3 NATs we've configured that should let internal traffic from the outside back in, 13.0.0.3. I should be able to ping that address. So this ping, the way the static NAT is working, this ping is getting delivered to this router to the address of 13.0.0.3. And this router is like, oh, I have a NAT for that for 10.1.1.2. So a static NAT is necessary if you want to allow traffic from the outside into your network. With dynamic and overload, we cannot let traffic in that way. So if I had a web server, which I don't have a web server over there. If I had a web server, here, why don't I put a web server over there? Yes. If I had a web server over here with this address, now from the outside I can browse. I should be able to browse to that by going to the NAT address I created. Yeah, so there we go. So in summary, we went through the configuration of the 3 different types of NAT the book covers. The dynamic overload is down here. We can have many hosts use one address with dynamic overload. A dynamic pool, here we can have many hosts use a pool of addresses as long as the number of hosts does not exceed the size of our pool. So if we have 200 hosts and we have a pool that has 50 addresses in it, then we're probably going to have problems. And then over here, we did static where we had a one-to-one mapping for anything from this host, always got the same address. Anything from this host, always got the same address. And this also allowed inbound traffic back to our host using those NAT addresses. So if you want to let traffic in from the outside, or you always want your host to get the same address going out, which might be useful and necessary for something like a mail server, then you use static. If you want to just let your host get out to the internet using and you don't care about the address and you want it to be as simple as possible, use the overload with the pat. And the only reason I could think you would ever need to use the pool NAT was if for some reason you had like a small number of addresses. Say you had 10 addresses that were in some special firewall rule somewhere that those were the only addresses allowed to get into the server, but you wanted many of your users to be able to try to get to that server, then you could use like dynamic.